So there's some wiring here. These are primarily most of the main switches for the panel, avionics, autopilot, I don't know, whatever. This one's ESP, inhibit. These are all lights. This is backup generator. This is the master and alternator switch. This is a starter button. Anyway, so with the vertical power system, all of your switches don't actually carry current. They're just active lows, which means when they are connected and the circuit is closed, that allows that circuit to be grounded in the vertical power box, and therefore no current actually flows through your switches. So I was thinking like, well, that makes things a little bit easier on the switch side, and I was wondering how I was going to do a sort of wiring bus situation for the grounds going in and out, right? So aside from this one and this one, I have to look at them. Yeah, I think aside from these two, everything else goes to the vertical power. This will be an active ground to the backup generator, the Monkworks. And this ESP inhibit actually goes to the the GEA 24 as a random input. Anyway, I thought about making these in such a way that I got one wire that goes out to the grounding block, because it really isn't all that, it's no current, so it's not a big deal. And then I was going to do 2 wires into each one of these and just sort of daisy chain them off of another. But then I got to thinking like, well, wait a minute here. If I do that and I have a partial failure on this one, that means every switch on down the line has a failure mode. I was like, okay, how instead do I do that? What do I do about that to keep the failure mode to a minimum? Now, yes, of course, single point of failure. If this comes off the ground block, of course, all the switches are fucked. Fine, whatever. It doesn't actually matter all that much. Does it matter? I think I might run a separate one for my generator. We'll see. I might run a backup line on that one. What would happen would be like the whole panel would shut down aside from the stuff that's always on, which is like the primary flight display, the engine monitor, basically what you need to fly. Anyway, aside from the single point of failure, which of course is always going to be a thing, you're going to find something somewhere every time unless you overbuild everything to every extreme. What I did was I took a trunk and branch approach. So I don't know if you can see both sides of this, but both sides of this wire is the same wire. And what I did was I just essentially, I don't have any ferrules. And even then, if I did, I don't know that I want to connect 4 wires into one. But I soldered 3 branches. All right, I'm going to stop you right there, Ryan. That was wiring switches, and let's go to where it actually ended up. I talked with a friend who does wiring harnesses as part of his job, and I ended up doing it a little differently, and for 2 reasons. One, he made some suggestions. I like them. For 2, what I had on the bench there, and I'm glad it happened now, before any of this is actually in the air. The solder that I had used, and I don't know why I use solder. It's brittle, it's whatever. Crimps are better for aircraft because they don't become brittle over time. Solder is a good electrical connection, but it is not a great physical connection. Now, if you're soldering and you're putting stress relief on it, that's fine, but make sure it's a good stress relief, like a solder sleeve with like flexible shrink tubing. Other stuff's not so great. Anyway, let's cut to what we actually did. So I'm gonna show you here. I did end up going back to the idea where each one ties into the next. However, what you'll notice on the end here is I've got one that comes in from the bundle of switches, so there's, and then one that returns. So I've actually got two ground paths, which, okay, ground loop, whatever, but for switches it doesn't freaking matter. What this is providing is a redundancy path, so that if any one of these crimps fails, only that, actually that switch probably won't fail because it has two paths back to the grounding block. All the white wires, of course, are what goes back to the VPX, and the black wires are the supplied ground from the ground block. So yeah, that's what I ended up doing, and this is actually a good segue because this is what it looks like when all of that got finished, and I really like the way that it turned out. Also, this like lack of support, I mean, the wires are supporting themselves. They're an ounce, and you know, even at what, 6G, it's not much weight at all. Those are going to be totally fine, and it's not like I'll be sustaining 6G in this plane very often, if ever. So yeah, there you go. Too bad, Ryan, from several months ago, you did it not quite right. You learned, and that's part of this build, right? You do these experimental aircraft for recreation and education. Yeah, that's what we say. We're going to take a break from this wiring stuff for a little while and go back to actual building of parts. I'm going to go to the canopy frame, the rollover structure, the rest of the metal parts, and then we'll come back to this wiring in a few episodes. See you there.